All right, how are we doing? Are we coming good on the... You got everything written down? You're not writing anything down. Write anything down. So, model orbital distance. But for planet column, you should write the planets down. You should have 8 planets. And then next to the diameter column, you should write down those planets' diameters. And then leave the next column blank, because we'll have to fill those in as we convert from real size planet down to our scale model.
What's the 5th one?
Model orbital distance. You'll be able to fill in regular orbital distance because we have that data. And then the last column we'll fill in as we convert. Okay? We're doing some metric to metric conversions today. We'll even go in the hall, if you guys are good enough. We'll spend a couple minutes out in the hall talking about our model.
Let's go.
Yeah, right? As you guys finish up, I'm going to start talking, okay? So try to pay attention. Web, you good?
Yeah.
Awesome. I appreciate the help. So the first thing I did this morning, when you want to make a scale model, you got to, first of all, you need to know the size of the actual object. So the most significant thing in our solar system is what? The sun. Good. The sun's diameter is 1.4 million kilometers. All right, so I'm going to write that up here. Actually, I already have it up there. And then you also need to know the size of the model you want to have. So I looked around the class, and really quickly I realized this is probably the best thing I have for about the size scale I wanted. So I took it, I measured it, I put one side up against the board, and I measured the other side, and I said that's about 28 centimeters diameter. So our scale is going to scale down the sun, that's 1.4 million kilometers across, down to 28 centimeters. So what you do to figure out what your scale actually is, first of all, you need to put them in like terms. So in other words, they both have to be either kilometers or they both have to be centimeters. Either way works. However, I chose to go from kilometers down to centimeters. That way all of our planets then too will be in centimeters, all right? So we're going to do the same way for all of them. So let me get my calculator up. I'm going to show you what I did. You can follow along. So we have our 1.4 million kilometers. Now, to go from kilometers to meters, I multiply by what? Kilometers or meters? How many kilometers are, or how many meters are in a kilometer? 1,000. So we're going to multiply our kilometers by 1,000 to get how many meters it is. Does that make sense? So we're going to multiply by 1,000, or we could just add 3 zeros, right? And then I want to go not to meters, I want to go to centimeters. So I need to go even further smaller in the units by 2 more zeros, right? Because 100th would have 2 more zeros if I multiplied by 100. So I'm just going to go ahead and do that. Multiply by 100 to get from meters down to centimeters.
That's a big number.
It's a big number. 140 billion centimeters is the sun's diameter across. Yes?
Are we putting this on like the 4th column?
You can put that off to the side somewhere, or below, or above.
Like the part that we're writing down.
We're doing the sun. The sun's not on our graph or our chart, okay? So we're establishing, great question. What we're doing right now is establishing what is the ratio going to be. 1 to what is going to be our scale. Does that make sense? So whenever you're doing a scale model, you got to decide what that scale is going to be. I'm using that and the sun. So I take the actual diameter of the sun in centimeters now, and I divide it by 28 centimeters for my model size. And I get 5 billion. What that means is our scale model of the solar system is going to be 1 to 5 billion in scale. Again, in other words, our beach ball is 1 billionth the size of the sun. Or flip it around, the sun is 1 billion times bigger than this ball. Does that make sense? Or 5 billion, excuse me. All right, next thing we got to do. And you guys are going to recreate this for the rest of the planets. I'm going to do Earth first, okay? follow the exact same process for the other planets. And I'll give you time to do that. So we have our scale, 5 billion. How do we use that conversion factor? So we have Earth's diameter at 12,800 kilometers. I want it down to centimeters, yes? So I'm going to just add 5 zeros. So 3 for the 1,000 to get down to meters, and then 2 more to get down to centimeters. So rather than do the multiplication, I know I just add 5 zeros. So 1, 2, 3, 4, 5. Now I have the Earth's diameter in centimeters. And then I divide by 5 billion. There you go, 9 zeros. Equals, so our Earth, 12,800 kilometers, add your 5 zeros, 1, 2, 3, 4, 5, becomes, it's the same size, but now we can call it 1.28 billion centimeters. Divide all that by 5 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, and I get 0.256 centimeter for Earth model. So that's the first one that's going to go, you can put here across from Earth in your model diameter in your chart. Okay. By the way, 0.256 centimeters is this right here. This is the model Earth. I'm sorry, it's white. It's not green or blue, but you guys see this? It's just a piece of chalk that's broke off. So if that beach ball is the sun, this is how big the Earth would be on our scale. Okay? Yeah. All right. Everybody get a chance to see that? Did you see that? There you go.
Wait, which column do I put that in?
Earth over to model diameter. So our model diameter for Earth is 0.256 centimeters, which is this size right here. Did everybody see the process? I'll go over the process one more time. You take whatever the diameter is in kilometers, add 5 zeros, that changes it from kilometers to centimeters. Divide by 5 billion, and that's your model diameter. Got it? Kilometers to centimeters by adding 5 zeros, divide by 5 billion, and that'll give you your model size in centimeters. So go ahead and do all those. I'll give you a minute, a few minutes, and then I'll show you how to do orbital too, okay? Again, Sun, Earth on our model, our 1 to 5 billion model, all right? Now, I want to ask you this before you go ahead and finish doing the same thing for the other planets. How far, just guessing before we actually do the math, how far do you think this will be from the Earth? In fact, come on up here, Brennan. Okay, I'm gonna have you take planet Earth, and I want you to go away from me.
Okay.
Like go away from me. How far away do you think it would have to be?
Well, like this compared to the sun?
Yeah. So this is the sun.
Well, I guess it's about as far away as I can get from you.
Is that far enough, do you think, or do I need to come this way a little bit?
Yeah, right there.
Right there?
Yeah, right there.
Are you sure?
Oh, I'm sure.
Okay, so that's like, I don't know, 25 feet, something like that.
Yeah.
Okay. All right, you think it'd be a mile away? A mile. Okay.
Or at least across the school building.
What do you think?
I disagree.
Toby, what do you think? Is that far enough? No? I'm glad, I like the way you're thinking. All right, how far do you think? Somebody said a mile. Come on. What do you think? You think it'd be less or more? More? Yeah, you're done. If you're still working on the other one, you can go back to it. You don't have them all done, okay? I just want to show you the process. So for the distances, when we're going from the actual orbital distance of these planets to the scale model, I don't want to go down to centimeters, I want to go down to meters, because when I'm measuring to actually show you on our scale model how far things are away from each other, it wouldn't make sense to use centimeters. It would make better sense to use meters. So that just makes it a little easier, right? So what we do, so for Earth, I'm going to do Earth again. 150 million kilometers is the distance from the Earth to the Sun. I want that in meters, so I'm going to add 3 zeros, as if I multiplied by 1,000. I'm just going to add 3. So I'm at 150 billion meters. The Earth is approximately 150 billion meters from the Sun. Now I'm going to divide by my 5 millionth scale to get the scale distance from the Sun to the Earth, 30 meters. Okay? Any questions on that? By the way, this room across is 45 feet, which isn't long enough.
You are wrong.
Well, he couldn't go far enough in the room.
Yeah.
Our Sun at about 28 centimeters, okay? We have our Earth. Oh no, what did I do with the Earth? There it is. It's so small, it's easy to lose. I put it on a white paper and it's a white piece of chalk. So there's our 0.256 diameter Earth. Let's see, Jupiter, we are saying, is about the size of a medium strawberry from my finger there to the end. And yeah, what about distances? We said the Earth was 30 meters. We're going to show, I'll show you that. Jupiter, again, was how much? 155 meters? And then what about Neptune? Wasn't that 900?
Yes.
900 meters. So we're going to go to the hallway and we're going to kind of demonstrate those distances, okay? Y'all ready?
Oh, I'm ready.
Let's go. So if the Sun's there, the Earth is 30 meters away, Jupiter's out in the parking lot, Neptune is out by the Country Mart somewhere close to that. There's more objects further out that are still part of our solar system. So if you got the Sun, you have Mercury, Venus, Earth, Mars, then what? Wow. Mars, then Pluto? There's something in between Mars and Jupiter. The asteroid belt. You were looking at my poster back there. That's great. So if you look at that poster back there, between Mars and Jupiter, there's an asteroid belt. And in the movies, guys, in the movies, they'll usually show like an asteroid belt, and the ship has to like bob and weave and like zigzag to get through and avoid the asteroids and meteors or whatever in the asteroid belt, right? In reality, you'd have to try to hit something because they're so far apart. Okay, there's so much distance between the objects. Then you'd have Jupiter with its system of moons. You'd have Saturn with its system of moons. You'd have Uranus and Neptune. And then you get into what are called the Kuiper Belt objects. Okay? So the Kuiper Belt includes things like Pluto, like Makemake, like all those small dwarf planets, right, that are in there. And then once we get out past the Kuiper Belt, there's a good amount of distance before you get to the last object thing that is in the solar system, which is the Oort cloud. And it's spelled O-O-R-T. And it's kind of where the comets hang out, because they come and swing in every once in a while, go around the sun real fast, but the journey is so long that most of their time is spent out in the Oort cloud. On our scale model, the Oort cloud would be like Shelbyville distance, okay? It's way out there. I want you to think about that because the sun on our scale model is this, and yet gravitationally, it has a hold of objects that are, 20 miles away on our scale? That's pretty nuts, right? Also remember, the sun, our solar system, interacts with neighboring star systems. Now, it's a weak interaction, but it's still a thing. So the gravitational force of our sun, however relatively small it is to the total size of the solar system, it's a powerful force. Yes?